Chapter 8, the mole concept. And when we talk about a mole in chemistry, it's not the little furry animal that's short-sighted and lives in the forest, right, or burrows under your grass. And it's not mole like a sauce, okay? It's actually a unit, and that's what we're going to learn about today. Atoms are very, very small, right? They're too small to count individually, and so we count them in groups. And counting things in groups is not a new concept to you. How many eggs is a dozen eggs? 12. Dozen is a unit in which we count by groups. So a dozen eggs is 12 eggs. Have you heard of the unit gross? Do you know what a gross is? A gross is a dozen. What would that be? 144. So a gross of pencils is not a bunch of disgusting pencils. It's 144 pencils. Paper is often sold by the ream. The ream is a quantity. How many pieces of paper in a ream of paper? I heard 8 and 100. I think 8 was, I misheard someone. How about 500? A ream of paper is 500 sheets of paper. These are counting units that we use in everyday life. So 500 is a large number, but it's still far too small to be useful in terms of counting atoms. And so we use something that we call Avogadro's number to count atoms. And Avogadro's number is right here. This is a very important number, 6.02 times 10 to the 23rd. So let me show you what that looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's how big Avogadro's number is. Right? That's really, really big. Mind-bogglingly big. Really big number. It's called Avogadro's number in honor of the scientist Amadeo Avogadro, whose research led us to come up with this number. It is sometimes referred to as the chemist's dozen because it means a certain number of things, just like a dozen means 12. But the chemist's dozen is this funky number. And this funky number is one of the reasons that we have to learn how to use scientific notation, because you cannot enter this number into your calculator without using scientific notation. I don't think anybody here has a calculator with a display that has 24 places, right? They don't make those. So where did we get this number from? Avogadro's number is equal to the number of carbon atoms that would have a mass in grams numerically equal to the atomic mass in atomic mass units. Now that probably doesn't make a lot of sense. That's like, what? Avogadro's number was chosen to make things convenient. We're like, well, how can you just make stuff up? All units are made up, aren't they? Who decided how long a foot was? I think it was originally based on how long the king's foot was, right? All units are made up. If we're going to make up units, we might as well make up units that are convenient. So we've talked about atomic mass and how an atom of carbon has 12 protons in it. No, sorry, 6. 6 protons. Carbon-12 has also 6 neutrons. Each of those particles in the nucleus has a mass of approximately 1 atomic mass unit. And so one atom of carbon weighs 12 atomic mass units. And so what we're doing is we're choosing this number. One atom is 12.01 atomic mass units. This many atoms is the same number but in grams. And so that makes things really convenient. So just to give you a clue as to how large Avogadro's number is, these are some illustrations from your book. If you took Avogadro's number of hydrogen atoms, which are the smallest atom, and put them side by side, they would circle the Earth 1,000,000 times. Atoms far too small to be seen even with a very powerful microscope. Avogadro's number of them, they would go around the circumference of the Earth 1,000,000 times. If you had Avogadro's number of Olympic shot put balls, the mass of them would equal the mass of the Earth. Now, Olympic shot put balls are heavy, but they're like, does anybody know how much they are? Are they 16 pounds? I'm not sure. About 8 pounds? So they're heavy, and yet they're not ginormous. You can hold one. Shot putters throw them long distances, right? Avogadro's number of them, same mass as the Earth. If we took Avogadro's number of softballs, they would occupy a volume about the size of the Earth. It's just a mind-bogglingly large number. It's just ginormous. What is the mass of one phosphorus atom? Got to look at the periodic table, right? Can't quite read it. 30.97? So on the periodic table, under P for phosphorus, it says 30.97. What's the unit on that for one atom? The mass of an atom is measured in atomic mass units. They got so creative with that name, didn't they? So one atom weighs 30.97 AMUs. What if we have Avogadro's number of phosphorus atoms? For carbon weighed, one atom was 12.01 atomic mass units. Avogadro's number was chosen so that Avogadro's number of carbon atoms would weigh the same number, but in grams. And it works for all of the elements. So if one atom of phosphorus weighs 30.97 AMUs, then Avogadro's number weighs 30.97 grams. Does that make sense? This is a really, really big number of phosphorus atoms. The number is the same, the unit is different. So one atom is that number in atomic mass units. This is the atomic mass off the periodic table. And this works for all of them. So, nitrogen, 14.01 is the number under nitrogen on the periodic table. That means one atom weighs 14.01 atomic mass units. Avogadro's number of them, 14.01 grams. That's why that Avogadro's number is convenient. Any questions? Yes?
Would it be 30.97 moles?
We haven't talked about moles yet. We're getting to that. Yeah, we're getting to moles. Any other questions?